how quantum computers work and why people connect them to the multiverse? Google's quantum AI founder said the performance gains lends credence to the idea that we live in a multiverse. The idea is that Willow might be communicating with parallel universes to finish calculations faster. What does that mean?
Yeah.
The computer we use every day and have been iterating on for the past several decades are what is known as a classical computer. Essentially, a classical computer utilizes binary as its language of choice. A bit in the smallest unit of data that a computer can store and process is like a light switch. Each bit can only be in a single state at a time, on or off, which is represented by 0 or 1. Computers track data based on the language of bits. Literally anything our computers do is based on a network of on-off switches sending a particular signal. A quantum computer is a bit different. If you're familiar with the concept of superposition or Schrodinger's cat, this won't be too far of a stretch, but a quantum bit or qubit is capable of representing the potential of multiple states at once. Rather than only recording a 1 or a 0, it records both because it can be both. This allows a chip like Willow, which has 105 qubits, to perform incredibly complicated analytics in a fraction of a time a classical computer could. And how does it work? So let's boil it down to a very small example. If you have 2 bits which can return a value of 1 or 0, there are 4 potential states that it can be recorded: 0, 0, 0, 1, 1, 1, and 1, 0. If each of these states takes 1 second to record, it would take a classical computer 4 seconds to record every possible permutation. A quantum computer made up of 2 qubits, however, would be able to send to record the potential of each qubit at once, meaning it can record all 4 possible states in 1 second. The real power here is achieved when you add a much higher number of qubits together and try to record every possible state. Once again, something that would take a classical computer far longer can be achieved quickly because a quantum computer can record a number of potential states at once rather than one at a time. Okay, we basically don't know what the fuck we're saying here. So AI's founder and lead, Hartmut Neven, said that the new chip had performed a purposefully complicated exercise called a random circuit sampling benchmark in 5 minutes. One of the world's most advanced classical supercomputers, on the other hand, it would take 10 and then 3 zeros, 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 years to perform the same exercise. That's 10 septillion years, which exceeds known time scales in physics.